Hello, and welcome to the presentation of the paper called quecat, a tool for unified querying of multimodal data. With the dawn of big data and their features, there have appeared so-called multimodal data, which enable to represent data information using a combination of existing models. Each selected model is chosen so that it suits the best the needs of the particular part of the data. However, this area is highly challenging because the combined models naturally have contradictory features. The multimodal structures are in general complex, and there exist no standards of which models should be combined, how they should be combined, how they should be accessed, etc. In our research group, we focus on efficient management of multimodal data, whereas for the purpose of unified representation of the data, we utilize the category theory and we introduce so-called schema category. It enables to represent any combination of existing popular models with all the specifics, all those order specifics. It can be viewed as a graph, and it provides strong theoretical background that enables efficient querying, transformations, etc. We have already introduced a family of tools for the purpose of modeling of multimodal data using this categorical approach, for inference of the schema category from sample data, or for evolution management. Today, I will introduce a new member of this family called quecat, which enables to query multimodal data represented as a schema category. So first, let's briefly look at how quecat works. On the left, we can see sample schema category, whereas the colors represent particular models or particular systems. On the right, we can see an example of a multimodal query over this category, which is expressed in our language called MMQL. As we can see, it was strongly inspired by Sparkle, because we didn't want to reinvent the wheel, and we want to introduce something that is well known to the users. In the second phase, the query is decomposed according to the borders of the models or systems into query parts, and these query parts are transformed into domain-specific languages and evaluated in the particular systems. The results are then transformed back to a categorical representation of the data called instance category. Again, it is a graph, but instead of structure, it carries the particular values. The partial results represented as instance categories are finalized to form the result of the query, which can be then, thanks to this unified representation, transformed to any desired representation, for example, into the relational model, as we can see here. So where do we get the schema category? This is Advocate, a tool which enables to model multimodal data using the proposed categorical representation to decompose the schema category into particular models and to map them to selected database systems. Having the schema category, we can import it into quecat, and we can specify queries over the graph representation using MMQL. Here we can see an example, whereas for the purpose of higher user-friendliness, the query is also expressed graphically in the graph representation. The nodes that are covered in the query have colors. The purple colors, in addition, represent projections. The yellow color or orange color represents, for example, filtering. As we can see, thanks to multimodal redundancy here, we can get two query plans which enable to evaluate this cross-modal query. The less efficient plan accesses relational model of PostgreSQL, key value model of Cassandra, and document model of MongoDB. Here we can see the particular query parts. The more efficient plan is the one which accesses only two systems, two models, Neo4j, that is the graph model, and MongoDB, which is the document model. The results of the query parts are transformed into instance categories, and when the query is finalized, it is represented in a unified way, and thus it can be expressed in any model, for example, using JSON.